So in this video, we're going to talk about NumPy Datatypes. So this is one of those more theoretical videos, but it's not really that hard. It's just about getting a very brief understanding of the native data types that comes with NumPy. So the question we are looking at is, what data types does NumPy have? This is a question. So let's just try it out. Let's make a new array. I can again just call it array. Let me just make it with the same numbers we had in the first video. It doesn't really matter. Numbers are not important. So let's run this. Now let's check out an attribute of array, namely array, then .dtype. This is short for data type. So here you can see that the data type is int32. So this is not just like the data types in Python where you have ints and floats and booleans and so on. Here they're more refined. Now I'm at NumPy's documentation page that Dina showed you, and here we have the data types. So you can see here that NumPy supports a much greater variety of numerical types than what usual Python does. So below here is the primitive data types, but they're platform dependent. So what we'll mostly focus on is the platform independent ones. So for instance, it has a NumPy int8, and this is an integer from -128 to +127. So you probably recognize this as 8 bits in size or 1 byte. So int16 is 2 bytes of integer information, int32 is 4 bytes, and so on up to 64. So hopefully this monster here is more than sufficient for what you're doing. It also has unsigned integers. This essentially gives you just the positive ones. So here you can maybe more clearly see that it's from 0 to 255, which is essentially 256, or 2 to the 8th possibilities. So this again represents 1 byte, 2 bytes, 3 bytes, 4 bytes, and so on. You can also notice there is a floating point version, which is float 32, and then there is float 64. You can see here that this float 64 matches the built-in Python float. There is also a complex 64. This has to do with complex numbers, for those who know, where you store two 32 bits floats of the real and imaginary part of that complex number. We're not going to go into complex numbers for quite a while, so you don't need to understand this at all. And the most important ones are segregated into integers, unsigned integers, floating points, and complex, and also variability in terms of how much storage is provided in terms of bytes. Now we're back in our document, and if you look at this creation here of array, I never really specified the data structure of the array, so then NumPy would just try to guess what I want. I only specified really integers, but if I would say make this 4.5 and run it, then it would just assume that, yeah, you probably want floats. So if we want to take more control, we can also specify the data type. So how do we do that? Let's again make our array. It's np.array. Here I pass in my list of numbers. You can just copy it from above if you want. Let me just write it. And as a second argument, you can pass in a data type, so dtype. Just set this to be equal to np dot, and now you can access all the data types as we looked at. So we saw that by default I would get an integer 32, but I don't really need that much storage, so it should probably be sufficient with int8 here. That will allow me numbers all the way up to 127, so let me just do that. Run this, and now I can look at array.dtype. You can see that it has been manually set to integer 8. If you're a beginner to NumPy, then this is really neat to know. However, you don't really want to set your own data types unless you know what you're doing. Say for instance that I have this array, and now I've set the data type to be integer 8. This means that it can store numbers up to 127. So if I now take my array and just set it equal to my array plus 100, this will just add 100 to all the entries. So here I have 104, 108, 150, 116, 123, seems good. And here I have 142. The problem now, if I print my array, is here. Here it just overflows, so instead of having 142, I get -114 because it simply loops around. This can create subtle bugs unless you have very good control of what you're doing, so I would actually suggest not to set your own data types, but just observe this is something one can do. Still, really nice to know, because later on, if you want to optimize a certain algorithm, then you can really squeeze out a bit more performance by specifying your own data types. So finally, in this video, I want to talk about 2 more attributes that's kind of cute. So one of them is the size of a vector. So to access the size of a vector, you can just do array and then the attribute size. And here we get 6. So you might be wondering, well, doesn't length work? We have the typical length function in Python. And here the answer is that, yeah, it does actually work, but it won't work for the higher order arrays that we'll talk about later. You shouldn't really use length that much when we're doing NumPy. It would be a lot more preferable to just use the .size attribute. Let me have this in a print statement. Secondly, you can also access the number of bytes that is used. So this is the array.nBytes. So the number of bytes is 6, because each of the numbers here are essentially 8 bits, which is 1 byte. So we have 1 byte, 2 byte, and so on, all the way up to 6 bytes. So this, as you probably understand, changes depending on the data type. So if I set this to integer 32 and run this cell, then here the array size doesn't change at all. It's still 6 elements, but the number of bytes does change because each element here now represents 4 bytes. So you get 4, 8, 12, 16, 20, 24 bytes. So these two attributes are just very convenient if you want to check out the vector, you want to see how big it is, and you want to see how much storage it contains. In the next 2 videos, we'll talk more about practical things, namely slicing and sorting. So I'll see you then. Hi everyone, so in this video we're going to talk about slicing. Slicing is something you might have done already in usual Python with lists. This is also possible with NumPy arrays. If you know about slicing from before from Python, then you can just skip this video or just tag along and see what we do. So let's start by making an array. So this will just be the same array we've previously used. Let me just manually pass in a list here. What slicing is that instead of extracting a single element from an array, we can extract multiple elements. So what I can, for instance, do is to take everything after a specific index. So to do that, I will make my array, and then instead of like taking in the number 3, which is definitely possible, I can take in everything after the index 3 by writing 3:. So now I'll get everything after the index 3, so at index 3 I have 16, then I also get 23 and 42. So the syntax so far is that I specify one number and then colon, then I get everything after that number. So for instance, if I do 2, I get this, if I do 1, I get this, if I do 0, I get everything. So if I don't specify a number at all here, then the default will also be 0. So this will just give me the same. I could actually specify an index that's way too big, so I could say everything from the 82th number and so on, and of course this will not give me anything, but I'll just get an empty array back. This is a bit different from just selecting things, whereas if I try to select something at the 82th index, I will, as you can see here, get an index error. But if I slice at the wrong point, I'll just get an empty array back. So let me return this to 3. So what I can also do is take everything before an index. So the way to do this is to take my array, and now instead of specifying a number and then colon, I will specify colon and then a number. So this takes everything up until the 4th index. So if I print this, I'll get 4, 8, 15, 16. And notice that 16 is at the 3rd index. So this takes everything up until, but not the 4th index. So I can again play with this, so up to 2 gives me the 0th and 1st index and so on. Again, if I specify a number that's just way too big, say 82, then I'll just take everything up to 82 that it can find in index, which is definitely all of these. So again, let me just return this to say 4. First, we took something before an index, now we took it after an index, but we can also do in between. In this I think. In this case, I can, for instance, do 2 colon, this gives me everything from the 2nd index and onward, but I want to also stop it at 5. This means that I'll get to things at index 2, 3, 4, but again, not at 5. So it's always exclusive at the last one. This gives me 15, 16, and 23. For me, it's a really good idea to just play around with this a bit. So if I do, for instance, 6, I'll get one more here. That gives me the last one. Doing higher than that, like 10, doesn't really make a difference at this point. I can also move this one upwards, say to 1. Or I can just remove it completely to 0. So let me go back to the one we had between 2 and 5. One thing you can note is that you can also use negative indices. So let me write that. So let me take everything starting from the 2nd index all the way to the -2nd index. If you see here, this will give us 15 and 16. We'll start at 15 because that's the 2nd index. Then I will get to 16. That's the 3rd one, but then here 23 is the -2nd index. Remember, we get -1, -2, and it's always exclusive at the last one. So this here, the 23 one, will not be included in my slice. So a very common way to now write, say, everything except the last one is just, yeah, I want to start from the beginning, and I want to go all the way up until the final one. From a few videos back, we saw the array range function, and that function could take in a third argument indicating like the step or how much you want to jump at each point. You can do the same here for slicing. So for instance here, I want to go from the second to the fifth one, then I just specify another colon and I want to do jumps of 2. So now I'll just get 15, I'll jump over 16, then I'll get 23. Combining these remarks about jumping and negative indices, you can do some pretty nifty things. Let's reverse an array. Let's see how I can do this. So I make a variable called reverse array. I have my array here, but what I'll just do is to say I want start from the beginning. I want to end at everything, but if I just have this, then, I mean, I've just made a copy of my array because this goes from the beginning to the end. But if I do another colon, then I can specify a step, and the step is -1. So I do a negative step. So this means that I take my whole array, but I'll do it in a negative order. And you can see here that it's reversed. For now, this is what I want you to know about slicing. When we deal with matrices later in the course, so two-dimensional structures, then we'll kind of revisit this whole slicing thing and see that it still works in that general setting. Thanks, and I'll see you again in the next video.